Hi everybody, welcome back. We're going to do more multiplying polynomials today. When we're multiplying polynomials, I want to look at this example here. Let's think about the area of each of these individual boxes. To find the area, we multiply. So this little piece is 2 times 8, which is 16 centimeters squared. Go to my next box. 2 times 6 is 12 centimeters squared. Then we go to this box down here, 4 times 8 is 32 centimeters squared. And finally, our last box, 4 times 6 is 24 centimeters squared. So if I want to know what the area of the entire box altogether is, I would add those all up. So I have 16 plus 12 plus 32 plus 24. 6 plus 2 is 8, plus 2 more is 10, plus 4 more is 14. 1 plus 1 plus 1 is 3, plus 3 more is 6, plus 2 more is 84 centimeters squared. We call this method of looking at the boxes the box method. Another way that you might take care of this is you might add up your sides. So what is 2 plus 4? 6. And then if we go to the length of it, what is 8 plus 16, or 6 is 14. And if you multiply 6 times 14, what does that give us? Guess what? It gives us the same answer of 84 centimeters squared. So these two ways are the exact same way. Sometimes when you find the area or when you multiply, you have to use this box method to make your information make more sense. So let's go ahead and get started. Letter A looks a lot like something that we were doing yesterday. So when we look at letter A, we have 3x and we're timesing it times every single thing in the parentheses. So if I look at the 3x, I'm timesing it times 2x to the third. So what's 3x times 2x to the third? Good, 6x to the fourth. Great job adding those exponents. Now I need to take that 3x and times it times a negative 4x squared. So what's 3 times a negative 4x squared? You're on fire. Negative 12x to the third. Great job. Now I need to take that 3x. I need to take that 3x and times it times my next term, which is 4x. Well, 3 times 4 is 12, and then I have x squared. And finally, I'm taking that 3x times that negative 1. So 3 times negative 1 is, good, negative 3, and I still have my x. So the way I would write this answer down is 6x to the fourth minus 12x to the third plus 12x squared minus 3x. And we call this the expanded form. Now, instead of having to write this down so many times, there's an easier way of looking at this. So I'm going to do this next problem, problem B, in green, since I kind of went and used up all the space using the blue. Using the box method, if we look here, we have a 1 by 2. I have one term, negative 2x, and I have two terms in the parenthesis, x cubed and a negative 4x. Notice I take the sign that comes before the term and put it with that number. So here, remember there's an imaginary 1. What's negative 2 times 1? Negative 2. And then we go to our x's. I have 1x here, 3 here makes 4. Let's go to our next one. Negative 2 times negative 4 is 8. Good. I have an x here and an x here, so that's x squared. So if I were to multiply this out, it gives me negative 2x to the fourth and a positive 8x squared. Good. So let's look at another one. You're going to notice that instead of having one number on the outside, I'm now going to have two numbers on the outside. So if we look at letter C, we call this a 2 by 2 because inside I have two terms inside each parentheses. So the first thing I'm going to do is set up my box. So here's my box. And I have two terms on top and two terms on the side. And I just take my numbers and my variables and put them in their correct places. So x and then minus 4. On top I have an x and I have a plus 7. Notice I take the sign in front of the number or variable. And now I multiply. What is x times x? Good, x squared. What is x times 7? Great, 7x. Down the bottom, what's negative 4 times x? Good, negative 4x. And finally, what is negative 4 plus 7? Fantastic, negative 28. If I were to write out all the terms that I have in the boxes, you would see, I'm going to start at the top and I'm going to keep going down the columns in this way. I have an x squared minus 4x. Back up to the top, I have a positive 7x minus 28. Is anybody seeing something we can combine together? Good. I'm glad you can maybe recognize this. Right here, those two guys are like terms. So I have x squared. What's negative 4x plus 7x? Good. It's a positive 3x. And I still have that minus 28 in the end. If you go back and look at your box, you'll see that my diagonals can be added together. Let's look at another example and see if this holds true. Again, I have a 2 by 2 because I have two terms in each parenthesis. So I'm going to box it out. There's my 2 by 2 box. On the left side, I have 2x minus 5. On top, I have x plus 7. Again, I took the signs that were in front of the variables. Now I multiply. 2x times x is 2x squared. Good. 2x times 7 is? Good, 14x. Negative 5 times x is? Fantastic, negative 5x. And finally, negative 5 times 7? Great, negative 35. Remember how we said about the box method? If you look at your diagonals, you can see that you can add them up. So those guys can be added up. So when I write this down, I have 2x squared. Now I'm going to go to my diagonals. What's negative 5 plus 14? Don't guess. Use your calculator to check your mental math. What's negative 5 plus 14? Good. It is a positive 9. Don't forget your x. And then finally, I have a negative 35 in the end. Fantastic job on that. The key here, when you look at your diagonals, always make sure that they have like matching terms. If they're not matching terms, you can't add them up. So I would recommend going and double checking that you took care of your exponents the right way. Let's go ahead and look at the next page. Oh man, letter E has 3x minus 4 in parentheses and then a little 2 outside. All that's saying is we're writing that parenthesis 3x minus 4 not once, but twice. So when I do the box method, it's still a 2 by 2. I still draw a 2 by 2. But in this situation, what I write on the left-hand side, 3x minus 4, is the same thing I write up top, 3x minus 4. Now, I know some of you are sitting there thinking, why am I multiplying these numbers on the outside? Think of it as figuring out the area of each individual box, like we did in that first example. So when you find the area of a square or a rectangle, you guessed it, multiply. So what's 3x times 3x? It's 9x. Don't forget there's those imaginary ones. That's where 9x squared comes from. Now, what's 3x times negative 4? Fantastic, negative 12x. Let's work down to the negative 4 now. What's negative 4 times 3x? Great, negative 12x. And finally, watch your signs. What's negative 4 times negative 4? Positive 16. Take a little look at those diagonals. Remember, we can add our diagonals. So if we look here, are these two guys like terms? They sure are. So when I look at this, that 9x squared stays where it's at. Now looking at my diagonals, I have a negative 12 minus 12. Nope, it's not 0. Double check your math. Use your calculator for this mental math if you need to. What's negative 12 plus negative 12? Good, it's negative 24x. And finally, we get a positive 16 in the end. Let's go ahead and do one more like this. So again, I have a 2 by 2. What I would like you guys to do is hit pause now and I will go through and work the problem out. Once you get done, then come back and look at my work and see if you follow the same steps. So hit pause now and work on this problem on your own. Welcome back. How did you guys do? Great. I'm so happy you got the right answer. If you didn't, double check your math. Did you take a -8 plus 18? Remember, that's really subtraction. That's where that 10C came from. Always double check with your calculator when we're doing these problems, so that way we know if it's a computational mistake or a process mistake. Let's go ahead and look at these next examples. We have G and H. You're going to see on these problems that they're a little bit more complicated than the others. If we look at letter G, you now see that you have 3 numbers inside the parentheses. So instead of it being a 2 by 2, now it's a 3 by 2. So when I draw this out, I'm going to draw 1, 2, 3 spaces on the left-hand side, but I'm just going to leave enough room for 2 on top. So looking at the first parenthesis, I have 2x squared plus 6x minus 1. Same idea, only now instead of having 2, I have 3 terms. Up top, I have x minus 2. So now when I multiply this out, what's 2x squared? Don't forget there's an imaginary 1. So what's 2x squared times 1x? Well, 2 times 1 is 2. X to the, watch your exponents. 2 plus 1 is 3. Good job. Now go to the next box. 2 times -2 is -4x squared. Now moving on to the 6x. What's 6 times 1? 6. Remember, there's a little 1 there. X times x is x squared. Fantastic. 6 times -2? -12. Don't forget your x. And then finally, my last row, -1 times 1x is -1x. -1 times -2 is a +2. So just like the other ones, something kind of neat happens here if you look at your diagonals. You see that these 2 diagonals right here are like terms. They have the same variable and the same exponent. So when I go through and write this out, I have my 2x third. Oops, sorry, let me do that in green. So I have my 2x to the third, just like before. There we go. So 2x to the third. And now when I get to that first set of diagonals, I can add them. What's 6 plus a -4? A +2x squared. Now I can look at my next set of diagonals. Again, you're going to see that when I look at them, I have like terms again. So I can actually add those up. They kind of look like little peanuts. So I added my red peanut. Now I'm going to add up the numbers in my purple peanut. What's -1 plus -12? Good, -13x. And then finally, what do I have in the end? A +2. And if you look here, double check your work, there's nothing more I can combine. The exponent on my first one is a 3. Let's kind of make this a little bit smaller for you. So the exponent on this first one is a 3. Then I say plus 2x squared minus 13x plus 2. I have it in standard form. Now some of you might be thinking, what if you arranged it this way instead? So say, for pretend, you were thinking differently and you said 2x squared plus 6x minus 1 on top and x minus 2 on the side. This is the same. It'll get you the same answers, but this time your diagonals that you add will be here. These diagonals would come together, and then your other peanut shell is that diagonal there. Okay. So if you have any questions at all, feel free to ask your teacher or rewatch the video. Otherwise, I feel like you have enough knowledge here to go ahead and work on today's classwork. The key here is make sure you take your time, watch your signs, and watch your exponents. Great job today. Thank you, and I'll see you all soon. Bye.